Welcome to another instructional video from Schwing America. The purpose of this video is to familiarize you with the digital proportional control system which is now used on many Schwing America products. The procedures demonstrated in this video are specific to a 42-meter using an FW20 radio remote. Procedures for other models equipped with the digital proportional control system may vary slightly. Consult the documents for your specific unit. This system provides the operator with precise proportional control of the placing boom and concrete output, as well as on-off control of the accessories. It is different from analog controls in that it communicates using digitally coded instructions. Communicating digitally provides several advantages over previous systems, including faster, precise response to operator control inputs. A digital system also provides easier, more precise tuning of the electrical system to the hydraulic system. And finally, built-in self-diagnostics help you pinpoint problems, reducing downtime. This video is meant to be a supplement to, not a substitute for, the service and operator's manuals for your unit. It is extremely important that you read, understand, and follow all of the safety instructions and warnings contained in the manuals supplied with and the placards attached to the machine. After watching this video and using the accompanying manual, you will be able to set up and operate the digital proportional control, understand how it works, locate the major components and describe their functions, use the manual adjustment terminal with the menu survey to navigate through the menu structure, set parameters, and troubleshoot system faults. Interpret the LEDs on the digital controller and control panels. Perform basic troubleshooting of electrical circuits and system components. Proper setup of the machine is essential to safe, trouble-free operation. Complete instructions are included in your operator's manual. After engaging the PTO, make sure the power supply is on. Set the mode control switch on the rear control panel to NA or local mode. Then check each of the emergency stop buttons, making sure they are deactivated. Set the machine up on the outriggers as described in the operator's manual. Then turn the mode switch back to the remote or fern position. Install the connector for the cable or radio remote in the receptacle. Make sure all the function switches on the remote are in the neutral position. There are 3 LEDs on the radio remote. The one on the left warns you when the radio battery voltage is getting low. When it starts flashing, you have about 30 minutes operating time before the unit shuts down. The center LED indicates when a digital message is being sent. The right LED lights when the emergency stop on the transmitter has been pressed. Turn the transmitter power on. The red light should flash. Pull off the emergency stop button on the radio remote control. The left and right LEDs should go out, and the center LED should come on, telling you the unit is ready for your instructions. Moving any of the controls will cause the center LED to flash, meaning instructions are being sent. While the unit is in operation, be aware that several conditions can cause it to shut down automatically. These include errors in the messages being sent, a failure in one of the electronic modules, or when using the radio remote, low transmitter battery voltage, or no control inputs for 30 minutes. You can also stop the machine manually by pressing an emergency stop button, either on the remote control you are using or at one of the emergency stop stations located on the unit. After you've completed the job, secure the boom in the transport position. Place all controls in the neutral position, push the emergency stop, and turn the radio transmitter power off. Turn the mode switch on the rear control panel to the local position. Then stow the radio. To make it easier to understand how the digital proportional control system works, we've divided this section of the video into two parts. First, we will identify the major components that make up the system, describing their function and how they fit into the overall system. Then we will focus on system flow, describing how these components communicate with each other and control the machine. The main parts of the digital proportional control include the remote control panels, which contain the analog to digital converters that translate movement of the levers and switches into digital code. Most concrete pumps are equipped with 3 control panels: the rear control panel, the cable remote, and the optional radio remote. The rear remote control panel is permanently mounted to the truck. It houses the mode switch, which allows you to switch between local and remote controls. For safety reasons, some functions may only be activated from the rear control panel. There's also a cable remote control, and because it communicates digitally, its cable is much smaller and lighter than those of the analog units. The optional radio remote consists of a transmitter and receiver. The transmitter is battery-powered and will operate for about 12 hours between charges, depending on the age of the batteries and the conditions you are operating in. The other half of the radio remote control is the receiver, which is located in the truck-mounted digital processor. It receives the digital code from the transmitter, checks to make sure the instructions are correct and complete, then passes them on to the digital processor. When using the radio remote, it is important to stay within a safe operating range, always knowing where the boom is. The radio remote is equipped with 2 frequencies that can be manually switched at the transmitter if you encounter interference from another transmitter or other source. All of these operator control panels communicate with the truck-mounted digital processor. This processor unit contains 3 types of electronic function cards and the radio receiver. The SCV9 card is the master card in the system. Its function is to coordinate the entire system by decoding instructions from the operator control panels, then sending commands to the appropriate slave cards. The SCV9 card holds all the programmed settings. It has been programmed at the factory for your specific machine. Replacement cards contain generic settings. In an emergency, they can be used as is, but they should be reprogrammed to match the hydraulic system on your machine. The HC2 and DG8 cards are known as slave cards because they receive commands from the master card, SCV9. Each of the slave cards controls specific functions which are determined by their location in the digital processor unit. The HC2 cards provide proportional control of the placing boom and concrete output. The HC2 cards send a 50 milliamp diagnostic signal generated by the SCV9 card, which continuously tests the various proportional electrical circuits. The DG8 cards provide on-off control of the concrete pump, horns, motors, and other accessories. The HC2 and DG8 cards contain no programming, so they can be exchanged or replaced freely with cards of the same type. The user's interface with the system is the Manual Adjustment Terminal, or MAT. The MAT is a handheld unit that plugs into the truck-mounted digital processor. It consists of an 8-digit alphanumeric display and a 4-button keypad. The MAT is used to navigate through the menu structure, allowing you to observe entries or to set parameters. Entries are non-adjustable values, similar to a gauge or meter reading. Parameters are the adjustable driver currents for the hydraulic valves. The MAT can also be used to perform signal tracing for diagnostic purposes. When the unit is in operation, operator control inputs are translated into digital code by the analog to digital converters located in each of the remote control panels. This code always starts with an identifier. Any commands received without this identifier are ignored by the system. This prevents the radio remote from responding to signals from cellular phones or interference from any other transmitting devices. The code is forwarded to the SCV9 card, either directly when using the cable remote or rear control panel, or if you are using the radio remote control, the code is transmitted to the radio receiver, which checks the code, then forwards it to the SCV9 card through the RS-232 bus. The SCV9 card interprets the code based on the parameters stored in its memory, then sends commands to the appropriate slave card through the RS-485 bus. The slave card determines if it can correctly carry out the command, then sends acknowledgement back to the master. If there are no errors in the code, the slave card sends a signal to the controlled device, either in the form of an on-off signal from the DG8 cards or a proportional signal from the HC2 cards. This proportional signal consists of a pulsed DC current which activates a solenoid-controlled hydraulic valve. This current causes the solenoid plunger to move against a spring. The greater the current, the farther the solenoid plunger moves. This, in turn, controls the speed of the proportionally controlled device. Before you can get the most from the programming and self-diagnostic capabilities of the system, you must first be able to use the MAT and menu survey to navigate to specific locations. In this video, we will be using software version 2.4. Think of the menu survey as a roadmap that allows you to navigate through the system software, and the MAT as the vehicle that takes you from place to place. Looking at the menu structure, we see it is laid out in columns. The first column identifies the electronic function card or digital controller card you have accessed. In software versions 2.2 and 2.3, the first digit in the controller abbreviation is a question mark. In versions 2.4 and later, an asterisk replaces the question mark in this position. The second column contains the main menu items. These begin with a question mark and branch out into the third column, which contains the submenus, also beginning with a question mark. In the display column are the entries and parameters used to monitor and program the system. If the information displayed in the MAT are German abbreviations, a brief translation is included to the right of the display column. Complete definitions of all menu survey items can be found in the DigiProp troubleshooting guide. Using the MAT to navigate through the menu survey is simply a matter of pressing the buttons on the keypad and noting your location with the alphanumeric display. To scroll to the right, press the P or program key. To scroll to the left, press the C or clear key. Use the arrow keys to scroll up and down. Versions 2.4 and later have two levels of menu access. Connecting the MAT automatically brings you to the customer menu. The second menu level, called the service menu, is hidden. To access the service menu, press the letter P to enter the main menu. Scroll down the main menu to System, then press P again. The MAT display now reads SCVS. Press the P key once, the C key once, and the up arrow key once. The display will now read NR 500. Press the P key again. A dotted line will appear in the display. Use the up arrow key to change the value in the display to 530. Press P again. A dashed line will replace the dotted line, meaning the setting has been saved. You now have access to the service menu items. With the digital proportional control system, you no longer have to adjust trim pots to fine-tune control response. You can now simply enter the parameters you want, and the microprocessor takes care of the rest. This is called balancing the valve currents, and it is necessary to provide precise synchronization between joystick control and boom movement. If the valve currents are not set properly, it will cause a dead area when moving the joystick near the minimum or maximum position, affecting the proportionality of the boom control. There are 3 adjustments or parameters to set for each boom section, as well as for slewing and concrete output. They are the minimum start current, the minimum stop current, and maximum driver current. The minimum start current controls how the boom reacts as the joystick is moved from the neutral position. It is the lowest level of driver current required to start the boom moving. Moving the joystick from the neutral position activates a microswitch. Immediately after the microswitch is activated, you should be at the minimum start current. This will provide linear proportional control when setting the boom in motion. If the minimum start current is set too low, the boom will not move with the joystick. This results in a dead spot as the joystick is moved off the neutral position and the microswitch is activated. Setting the minimum start current too high will cause the boom to start abruptly and bounce after the microswitch has been activated. The minimum stop current controls how the boom slows to a stop as the joystick is moved to the neutral position. It is the precise point at which the driver current falls below the level necessary to keep the boom in motion. After the driver current reaches this setting, the microswitch should deactivate. This allows the system to go to the 50 milliamp diagnostic level. If the minimum stop current is set too high, the boom will be moving too fast when the microswitch deactivates, causing it to stop abruptly and bounce. If it is set too low, the boom will stop before the microswitch deactivates, and you will have an increased dead area. The maximum current setting controls the amount of driver current available. When properly adjusted, the hydraulic valve should just contact the mechanical stop as the joystick reaches the 100% position. The procedure for setting the valve currents requires the use of the MAT and menu survey. First, find the value you want to adjust in the display column of the menu survey. These are located in the PAR section of the main menu. Then chart a course back to the SCV9 starting point. Use the MAT to scroll to the desired location and observe the current value. To change the setting, press the Program key once. A dotted line appears under the alphanumeric display. The value can now be changed. Press the arrow keys to adjust the value up or down to the desired setting. If you make a mistake, press the C key to start over. When the parameter is set to the desired value, press the Program key again. The dotted line changes to a dashed line, indicating the change has been saved. After setting the driver currents, check the operation of the hydraulic valve by watching the boom and the handle on the hydraulic valve as you move the joystick. The boom should just start to move as you move the joystick off neutral and you hear the microswitch activate. Then move the joystick to the 100% position. The handle on the hydraulic valve should just contact the maximum stop. Correctly balancing the valve currents precisely tailors the digital controller to the hydraulic system on your unit. This provides smooth proportional control of boom functions and concrete output. The initial settings that were programmed into your machine are located on a decal near the digital processor. The digital proportional control is designed with high-tech self-diagnostics built in to help you quickly and efficiently locate faults in the system. When the unit is activated, it continuously monitors the systems and communicates their status using LEDs located on the digital processor. These messages can be easily interpreted using the DigiProp troubleshooting guide. The troubleshooting examples demonstrated in this video will focus on the truck-mounted control unit. Troubleshooting charts for the LEDs on the radio receiver are located in the FW20 operating manual and the DigiProp troubleshooting guide. When the system is activated, the LEDs on the SCV9, HC2, and DG8 cards should show steady green. This means that no faults exist and the system is ready to operate. If all of the LEDs are off, it indicates that there is no power to the unit, probably because an emergency stop button is pressed or the main power switch is off. When the MAT is plugged in and communicating with the system, the light on the electronic card you are reading will glow steady red. The SCV9 and HC2 cards may also flash red, indicating a hardware problem, such as a wiring or connection problem. If the SCV9 is the only card flashing, it means the problem is intermittent, possibly a bad connection. It continues to flash because it stores fault information in its memory until the system is reset. Resetting the system can be accomplished either by turning the power off and on or by using the MAT. If a problem exists, for example, the boom section 2 down function is not working, the following troubleshooting procedures apply. The first step is to check the status of the LEDs on the digital controller. If the card that controls the problem function is flashing, along with the SCV9 card, there is a hardware fault somewhere between the output of the digital processor and the hydraulic valve. To determine if the problem is the solenoid or the wiring, swap the solenoid caps. If the problem is unchanged, boom 2 down is still not working, replace the solenoid. If the problem follows the solenoid caps, that is, boom 2 down is now working, but boom 2 up is not, the problem is in the wiring. You should consult the electrical schematics or call Schwing America service for assistance in tracking the fault. If the boom 2 down function is not working and the LEDs are steady green, the fault is upstream of the HC2 card. You'll need to use the MAT and menu survey to pinpoint the problem. To do this, first connect the MAT and scroll to the PAR main menu, then to the boom 2 down display. Check the minimum start, stop, and max current parameters. They should approximate the values written on the decal. If not, reprogram the function to the correct values. If the parameters are set correctly, scroll to the P out main menu, then to the boom 2 down display. Move the joystick and watch the value. When the joystick is at the neutral position, the reading should be 50, indicating the 50 milliamp diagnostic current. As the joystick is moved towards the 100% position, the reading should rise to the max current setting. If these functions are not correct, try using the other remote control panel. If that doesn't help, or the readings are correct but the boom function still is not working, call Schwing service for help. If none of the control functions are working and the SCV9 card is steady green, but the other cards are off, it indicates a communication error between SCV9 and one or more of the slave cards. To locate the problem, connect the MAT and scroll to the INS main menu. Then scroll to the CERR display, which is the entry for communication errors. The number 6 in the display means that the first error occurred with the 6th card to the right of SCV9. To determine if the problem is on the card, swap it into another position of the same card type and reset the system. If the error follows to the new position, the board is defective. If the error is still in the 6th position, call Schwing America for assistance. In an emergency situation, you may be able to continue working by turning off the defective board and performing its functions manually. To do this, swap to the service menu as described earlier. Then turn off the functions controlled by the defective board and reset the system. You can now operate those functions manually. This concludes the digital proportional control video. We hope you find it useful in the daily operation of your equipment. We at Schwing America are dedicated to building the finest equipment available and providing the training and information you need to get the most from it.